Okay, so we are going to start working on problem 81 here, try and get you a good shot of what we're looking at. Okay, again, follow along your book since this view of the problem is not always awesome. But problem 81 is referring to the chart here, figure 2.24, position time graph. So it's referring to the problem 80 in figure 2.24, which is the figure that you're looking at. Calculate the father's velocity for each segment. So we're simply just calculating the velocity for each segment on there. Now, hopefully we know by now that to calculate velocity, we look for the slope of a line segment. Okay, so we want to find the slope for section A, section B, section C, and section D. Okay, section A, slope is the velocity. So rise goes from 0 to 2. So our rise is 2. And our run is 1. 2 over 1 is 2 meters per second. So we'd write over here for part A for 81. Weird looking A. Okay. Velocity is equal to our change in position over time. Final position minus initial position divided by time. Still looking at this chart. Your final position for that section, 0 to 1 seconds, is 2. Your initial position was 0 over a time of 1 second. So your velocity is quite simply 2 meters per second. Now part B, we again find the slope. Okay, part B is a horizontal line. We just stand flat there. There is no rise. So for our velocity, our slope, delta x over t, x final minus x initial, really writing it out here, x final minus x initial. Okay, your final position is 2. Your initial position is 2. 2 minus 2 divided by 1 second, 0 over 1, which is 0. Okay, and we should probably just recognize by now that the slope of a horizontal line is always going to be 0. Now, if we're looking at section C there, section C, the rise, okay, in 1 second, the rise goes up from 2 to 3. So x final is 3, x final is 3, x initial is 2. So 3 minus 2 divided by 1, which is exactly what we write over here. Delta x over t. X final minus x initial over t. X final was 3 meters. X initial was 2. We went in a time of 1 second. So 3 minus 2 is 1 over 1. So 1 meter per second. Section D. Okay, this last section, okay? It's a little bit longer. Okay? This, okay? Rise over run. Change of position over time. Now, your final position is all the way down here. Your final position is 0. Your initial position was 3. And you did that in a time period of 2 seconds. Okay, so if we look over here, delta x over t. X final minus x initial over t. X final, your final position, is 0. So we just write 0 minus your initial position, which was 3, divided by the time that happened. Now, how much time went by here? From here to here, 2 seconds went by. So t is going to be 0. Okay, negative 3 over 2. So that winds up being negative 1.5 meters per second. It is a negative velocity. Okay, so there's our work next to that chart. Okay, we can see that there, 2, 0, 1, and negative 1.5. Now in that last section, negative 1.5, okay, that line's going down. This is a negative slope from left to right. If it's going down, that means that your slope is negative. The slope is a change in the rise over the run from left to right. So if your position went down, it's going to be a negative change in position, a negative delta x divided by some amount of time, in this case 2. We went down 3. That's your rise, negative 3. And your run is positive 2. Okay, so that's number 81.